Tonight we will hear from Dr. Larry Hoffman about observing in a light-polluted world and the wonders of electronically assisted astronomy. Lawrence Larry Hoffman is a retired ophthalmologist. He moved to Detroit in 1940 when his father got a job as an optician. He attended Detroit public schools and Wayne State University, working as an optician until he entered medical school. Larry got his MD in 1962 from U of M. He trained in ophthalmology at the Kresge Eye Institute in Detroit Sinai Hospital. He practiced ophthalmology in Farmington Hills, Novi, and Detroit, specializing in microsurgical cataract surgery until he retired in 2012. So he has done a lot of protection of people's observing. He was on the teaching staff at Detroit Sinai Hospital and the Kresge Eye Institute for many years while practicing. Larry got his first look through a telescope 70 years ago and has been hooked on astronomy ever since. In high school and college, he attended meetings at the Detroit Astronomical Society and ground his first mirror for an 8-inch Newtonian in a basement off of 2nd Avenue. He remembers when you could see the Milky Way from Broad Street in Boston. Over the years, he has had a wide variety of telescopes and mounts, strongly believing that you can never have too many scopes or too many mounts. He currently belongs to 2 astronomy clubs in Michigan and 2 astronomy clubs in Florida. His motto is, when you stop learning, you are dead. It's just that nobody bothered to tell you. Ladies and gentlemen, I give you Dr. Larry Hoffman.
Good evening all. Before we get started, I want to thank especially one person who really got me interested in video astronomy. That's Bob Berta. And all of you, I hope, know him. It was astronomy at the beach, and he had a telescope out there. I believe it was a Hyperstar telescope with a Estelle Cam on it. And that's where I got my first good look at video astronomy. Before that, I had been looking into it, but that got me switched to it. Now, the picture you're seeing up on the screen now is my favorite astrophoto of all time. And some of you may recognize it. It's called Moonrise, Hernandez, New Mexico by Ansel Adams. Now, we're going to talk tonight about video astronomy, which is also called Electronically Assisted Astronomy or near real-time viewing. We want to know what it is, why we do it, and what equipment that you need. Now, I'm sure that most of you don't remember when skies were clear around Detroit during and after World War II and up through the Korean War. They were clear because there was no light pollution. We had to have blackout shades on all of the houses. We had to have blackout shades on our houses. People didn't drive at night because, number one, it was too expensive to get gas, even at 30 cents a gallon, and we had to have coupons to buy the gas. But over the years, I had quite a few telescopes, and 12 years ago, I was starting to look at retirement, and my wife decided that she had to get me out of the house somehow, so she said, go buy another telescope and get out of the house, which is what I did. So,
what a wife!
Funny story for you. My wife was complaining about what I spent on my hobbies to a friend of mine who unfortunately is now deceased. And he made the comment to her that all of his clients either tooted it up their nose, drank it away, gambled it away, or spent it on other women. And then he said to her, which would you prefer? She hasn't said a word about my spending on my hobby since then. Well, about 12 years ago, I decided to buy another scope, and I bought a mount like this, which is an Orion Sirius mount, and I bought a telescope from Teleview called an M51 which I still have. The mount is long gone. Does anybody remember John from Ryder's Hobby Shop?
Yeah, sure.
I got it from him. This is the scope I bought. It's an extremely nice scope. It's still sold today. You can find it on the TeleView website, along with some photographs taken by photographers, astrophotographers, that are just absolutely beautiful. And it's a great scope optically. But along with the scope and the mount came this book from TeleView. Ken Brown took it with film. It was before the digital age. And he stated in the book that the average amateur should be able to see all of the Messier objects with a 3-inch or 4-inch telescope. Now, I hope everyone knows what a Messier object is. It's a list of objects that a French astronomer by the name of Charles Messier made up in the 1700s. He was a comet hunter, and these things got in his way, so he made a list of them. The list outlived him. Incidentally, the English don't like the Messier catalog. They made up their own. God bless the English. But the reason that we couldn't see those objects is because of this. This is the Bortle dark sky scale. And you notice it goes from 1, extremely dark, to number 9, inner city. We're somewhere between 5 and 7 around here, which means we're not going to really see a lot of telescope objects without help. Now, knowing that I couldn't see anything, incidentally, I decided early on that I didn't really like visual astronomy. Number one, I had a backache every time I took out the telescope from bending over the eyepieces. It's very satisfying, and I liked it a lot, but I realized quickly that it wasn't for me. Now, some friends of mine down in Florida convinced me I should become an astrophotographer. So, I started taking astrophotographs. And it's very satisfying, but it's expensive and time-consuming, and you can get better pictures than I ever took off the internet. So I decided it really wasn't what I wanted to do. And I haunt something called cloudy nights. I hope all of you have read it or seen it on the internet. And I came across an amateur astronomer from Oakland, California, actually Livermore, by the name of Zhiyun ASI. He belongs to the club at Scheer Observatory in Oakland, and I went looking for him a couple times. My daughter lives right down the road from there. Unfortunately, I never got a chance to meet him, but he was taking pictures using a Estelle Cam3 video camera and getting amazing results that he put on his website. He had then switched to using it as his guide scope. Now, Jim gave up on the Estelle Cam a while back, but I didn't. And what happened is I went to astronomy at the beach, and Bob was there, and I realized this is something I wanted to try. So I went out and bought the Estelle Cam. Now, we want to know what is video astronomy, why to do it, and how to do it. Well, definitions vary, but here's what I think. It's about observing an object as close as possible to real time, not collecting data for later. Instead of an eyepiece, using the sensitivity of a camera to enhance your view of an object now, not later. It's about exploiting software, either in a camera or on a computer, to enhance your view of an object now, not later. Most purists in video astronomy will agree that if your post-process is not video astronomy, it's imaging. And on cloudy nights, it's lumped into a group called EAA, Electronically Assisted Observing. Now, the question is it imaging or observing? And the answer is, it's both and neither. It falls right in between them, and there are many similarities with both. Now, it's been around, video astronomy has been around since the late 1920s. You know, video cameras really go back about 90 years. It's hard to believe that they're that old. But around the late 1980s or early 1990s, amateurs began to experiment with inexpensive CCTV security surveillance cameras. The earliest one that I remember was a Samsung video camera and a Philips 2U cam. Now the problem with all of these is how do you control them and how do you get everything working so you can see what you want to see. Now this is the basics of a video astronomy setup. It's a telescope, and it can be a very cheap one, it doesn't have to be an expensive one, with a camera attached and a video monitor. Now the next step was adding a computer and using something called a video grabber card. And let's see if I can show you the grabber. This is the grabber. Right here. I'm sorry, right here.
There it is.
There it is. They are the bane of my existence. The problem with a video grabber is every time Microsoft does an update on Windows, it doesn't work, it stops working, because all of the drivers have to be reloaded. Now, why we do it, why do we do it? We do it so we can see. It has some very interesting effects. It increases the light grasp of what we're looking at by somewhere between 3 and 10 times. So a little 4-inch telescope can act like a 40-inch telescope.
It's incredible.
And strangely enough, it cuts through light pollution. And it'll cut through water vapor to some extent also. Now, the man who originally made up the center portion of my presentation is English. And so he wanted to show what you could see from downtown London. Now, the other good thing about it is it's a great outreach tool. I hope that most of the people here have telescopes and you've taken them out to a star party. And first thing that comes along is a little child who knows he or she has to move the telescope or touch everything that you have.
Especially the
This way they can't touch them. So it allows enjoyment of astronomy for those with difficult or aging eye conditions. You can read this as well as I can, maybe better. Now there's some drawbacks with doing it. It can be difficult to set up, operate, and take down. And the use of projectors, monitors, and laptops produces problematic stray light for everybody around you. And everybody remember Murphy's Law? Anything that can go wrong will go wrong. It does it for this too. And it's got for some people, it's got a very steep learning curve. So what equipment do you need? You need a camera, and a telescope, a monitor if you're using analog, or a computer if you're doing it digitally. We're now moving from USB 2 to USB 3, and there's a reason for that we'll talk about in a couple minutes. You can use an ordinary Canon camera or a specialized camera. And I've, at this point, moved on to specialized cameras, as you'll see in a minute. And this is just a spectrum of the cameras and the sensors that are available. And this is pictures of some of the cameras that are available. You know, we go through thinking that this particular brand or that particular brand is better. And astronomical cameras are like that too. For a while, the Starlight Express cameras were the best. Then it was added cameras. Now it's Zhiyun ASI. But just about any telescope will do, as long as it can reach focus with the camera. Aperture is less important than focal ratio. The shorter the focal length and the faster the scope, the better. Since many of the cameras have small sensors, you really can't use too long a focal length because your field of view will be too narrow. And one of the most popular and the best ways is an SCT with hyperstar, like Bob was doing. As for mounts, you can use an equatorial mount or any kind of mount, really, like the SCT mount. And most people end up using a focal reducer or a Barlow lens to make the focal ratio faster and decrease the focal length. And you can, as we said before, you can feed the picture to a monitor or a laptop. Actually, I'm going to go back one, if we can.
The other way. There you go.
There's that video grabber again. I wish somebody had never invented it. And I wish that Microsoft would stop updating Microsoft Windows 10. Now there's a bunch of software that you can use, and we're going to be over the technical stuff in just a minute. MiloSlick is great, but the problem with MiloSlick is for Malin cams only, and it uses a video grabber. Infinity software is great. Lodestar Live is the one I use most of the time. Astro Live is gone. SharkCam is the newest one, the latest one. I use that now too. And Astro Toaster. I don't know who makes up the names on these things. Astro Toaster works with DSLRs. And you want a place where you can set up. And what can you expect in video astronomy? It increases the light grasp of your scope by 3 to 10 times. It's great on dim objects like galaxies, nebulae, and globular clusters. You don't get the shimmer of open clusters. You can't compete with the dynamic range of the human eye, however, and you won't get photographic quality views for only tens of seconds of data and no processing. So forget about getting the fancy pictures like you see in National Geographic. You ain't gonna get them. But look at the difference. The one on the right is a processed video picture, astro picture. The one on the left is a video picture taken in just a couple of minutes by somebody out could be in their backyard. Now, these are the video cameras that have been available, and there's a whole list of them. Look at it and forget it, because they're not going to amount to anything. But this is the camera that Bob had, the same type, and the one that I bought. It's called Estelle Cam3. It's actually made in Japan and called the Wacom or Wacom. I prefer to call it the Wacom. It plays back through a video monitor or a TV. And here's just a typical setup done with it. Now I bought it. The first time I used it, I put it on a Hyperstar Celestron 8-inch scope. It was on the back deck of my condo, and I turned it on, and I saw things that I had never seen before and that I'd always hoped to see. I went through about 20 of the Messier objects in about an hour. You can do it that fast and see them. I had never seen M101 before. I'd never seen M1 before. It was an eye-opening experience, if you'll forgive the pun. Now, after I bought that, of course, you know, there's advertising, and there's the Camera of the Month Club on the internet. And I ran into this advertising from Malin Cam. Rock Malin is an engineer in Ottawa, I believe. who designs and builds cameras. And he had what was the camera of the moment at that point, called the Malicam Extreme. So naturally I had to have a Malicam Extreme. And I ordered a Malicam Extreme, and it came instead of a Malicam Exterminator, because the Extreme was no longer even being made. Now, there were better places I could have sunk my money, I can tell you that. The problem is it's a hybrid camera. It's an analog camera. Does everybody know the difference between an analog and a digital camera? All cameras put out a digital signal. An analog camera has a circuit that will convert it so it can be used on a TV or a monitor. A digital camera puts out a signal that can be used on a computer. Now, if you want to use an analog camera on a computer or a, anything like that, you have to use one of those frame grabbers like I showed you before. But, take a look at these pictures. These were all probably done, 3, 4, 5 minutes each, using the Malicam. Now, he still makes them. I don't think he sells very many of them now. And this is the software that comes, that you actually have to buy separately. He sells or sends out a program with the cameras, but this is the program that most people use to control it. It's a great control program. I love it dearly, but I still don't use my Malicam anymore. But I want you to take a look at this picture. This was shot from my dining room table through a plate glass window about 1/3 of a mile away at some telephone poles across the lake. And I was amazed that I could see that easily. It's not that clear, and it's in color, but it's what I could do at that point. And there's a reason I wanted to show it, because I want to show you the same picture taken with a more modern camera. And I took this one last winter. I've got a condo down in Florida. I put the same camera on my dining room table in Florida, went about maybe half a mile to a condo across the way, and took that picture. You probably can't tell, but there's a lot of noise in the sky, and it's not quite as sharp as I'd like. Now, of course, right after I got mine, another one came up. This is called the Revolution Imagery. It's very popular. It's still being made. It's only $300 for the complete kit. It comes with everything you need. Comes in a case like this with the camera. And this is the back of it. And the pictures are just as good as you got with the Malicam for 5 times the price. I think they're still making them, but I think he's about to phase them out. And here are some more that were taken with that. It just takes a couple minutes to take a picture like that. They're great. Now this is a typical setup with a cheap meat scope. A little bit bigger view, the same, so you can see what it is. And you can see the camera right there. It just sticks into the diagonal. The reason for the diagonal is because you're going to be sticking out too far if you don't do that. This relieves the weight on the back of the telescope. And here's another one. Excuse me. Here's somebody who just did it with a camera lens. Now, I hate to put up tables, but I did this on purpose. Take a look down this column. You see how small each of those sensors is? These are called 1/3 inch, which means that the diagonal is only 6 millimeters. There's nothing there. And this is something that anybody interested in astronomy should know. This is called the Bayer pattern. Bryce Bayer was an engineer for Kodak. And they were trying to figure out how to get color out of black and white TV. He made this program up, and it's caught on and it's still on for today. There's one camera that uses the X-cran system. Everything else uses the Bayer pattern. Bayer died in 2011, and he was an old man when he died. But of course, right after, I decided to buy the Revolution Imager. Luckily I didn't, because right afterwards, this came on the internet. There's a man by the name of Paul Scheer in England. So many of these advances take place in England. Paul Scheer came out with a program to use a guide camera from Starlight Express called the Lodestar and turn it into a camera that would take pictures. Now, these were taken from his backyard in downtown London. He's got pictures on the internet of his observatory. He's actually built an observatory around it. It's a great system. This is still my favorite. It's another one with a small chip. The chip is still a 1/3 inch chip. I don't know who named these chips. It's got nothing to do with 1/3 inch. But somebody tacked names onto it and stuck. This is the camera. This happens to be my camera. I have both the color and black and white, but I really like the black and white better. And this just talks about the difference in the size of the chips. Now, over here is the Lodestar. That's the one we talked about and that I had. Now, Starlight Express got the idea that they could really use a bigger chip. So they made the Ultrastar. And it goes up from being half a megapixel to being a megapixel and a half. Which it doesn't sound like much, but it's a lot. It makes a big difference in the quality of the picture. It's still being sold and made today. Now, this is a typical picture taken with that Ultrastar. You notice how sharp and smooth it is compared to the other pictures? And this is the Ultrastar itself. This is an Ultrastar picture. And this is the program that Paul Scheer wrote, Starlight Live. And this is just a screen grab. It's amazing how much you can see from a light-polluted city. Here's some more pictures taken on it. Another one. And you don't have to be a great astrophotographer to get these. You don't have to spend hours taking pictures and hours, processing them. Another one. M16, you know what that is? The Trifid. M51 Whirlpool. Now, not to be undone, or outdone, a company by the name of Attic got the same chip and made their own camera and wrote their own software. And this is Attic software. I haven't tried it. It works well. A lot of people swear by them. They're still being made and sold today. This is M1. But it's not being processed the way an astrophotographer would. See the ring up there? Does it show up? I can't tell from here. Yeah. Okay, it's called a dust bunny. There's a spot of dust on the front of the camera, the chip. But this is the kind of results you can get with it. It doesn't take much work to do. You don't have to be a genius. The software does it all. These are just typical pictures taken by somebody in their backyard. Now, anybody ever heard the term steam engine time? It's an old engineering term that means that when it's time for something to be developed, somebody will go ahead and develop it. And usually it's more than one person. It's usually several people. James Watts is credited, of course, with developing the steam engine. But he didn't develop a steam engine. Number one, he was the first person to patent it. Other people developed it at the same time. There are 4 or 5 other people. And actually the person who developed the steam engine was a man by the name of Scheer, who was a Greek Egyptian back in the 1st century AD. But steam engine time came to us, and Robin Glover, another Englishman, realized that there was a market for this sort of thing, and he developed a program called SharkCam that you could use with almost any camera you wanted and get fairly good pictures without much work. Now, it started out as in 2011 as a program to do pictures of the planets, and he realized that there was a market, and so he started developing it. It's now probably the most used program for video astronomy. We've gone from using, the first 3 cameras I showed you were analog cameras. They were CCDs. Cameras now have changed to CMOS, complementary metal oxide semiconductors. Now, his program will run with a whole bunch of different cameras. Some of these are not available in the States. You know how the English are. They're not going to send us everything they have. And they're going to charge us extra duties on the stuff we send to them. But this is some of the things that his program can do. Polar alignment, live stacking, flat correction. I won't go through the whole list. You can read it as well as I can. But the most important thing on there is polar alignment. One of the things that I learned when I was starting to use my German equatorial now is how hard it is to polar align a telescope. The better aligned it is, the better your go-tos will be. So you can find things. You can see what you want to see. Well, about 4 or 5 years ago, a company from China, QHY, owned by a man by the name of Dr. Qi, came out with a little camera and a program that would get you better aligned. And it did that by taking pictures at several different spots, figuring the center of where the rotation was, and then just putting it over the true pole. The camera comes with a computer program, and it's absolutely great. I wouldn't work without it at this point. Now, Robin Glover realized that he could do it with his system. So he adopted the software for his computer program, and it's now an absolutely great way to polar align your scope. I hope that a lot of you have German equatorial mounts. You know how hard it is to get them polar aligned. But boy, this solves the problem. Now, this is a typical screen using SharkCam. Look how sharp and clear that is. And another one. And another one. These are things you could never see, even with a 10-inch scope with your bare eye. But it's easy to do in your backyard using this program, and some of the cameras are available now. Now this is the screen used on polar alignment. And another picture, a full screen of a picture. Now, remember we talked about steam engine time. Well, things keep developing. And a company from China, Zhiyun ASI, brought out a camera that is now the cream of the crop for astrophotography and for pictures like we've just been showing video. Now you remember that first picture I showed you, how blurry it was across the lake? Much better. This was taken during the day from that dining room table I had. Nice picture, isn't it, for daylight picture? It was taken at 5 a.m. with a 4-second exposure. The camera is that sensitive. But look at that there. Took me a while to figure out what it was. It was my wife's chair on the back deck. Now this is a typical picture taken with that camera. I bought one, by the way. I love it, absolutely love it.
What's it run?
This is M1. You can, if you look up here, it shows you how long the exposures were and how many of them. He stacked them. This is 15-second exposures, but he did 81 of them. The software does it automatically. Another one. I don't know which collaborator that is.
Sounds great.
M51.
Could be M91 too.
I believe that's a cat's eye. This is 15 seconds
Spark.
at M81. M82. 30 seconds by 32.
M20.
Every one of you can do pictures as good as this with just a little bit of practice in your backyard. And you don't have to spend hours on hours making pretty pictures that nobody's ever going to look at again. And that's the problem with astrophotography. Most of the astrophotographers that I know that are really dedicated, they stay in it for a while, then they get out because they realize they're photographing the same thing over and over. They'll go out 4 or 5 times a year, spend hours making a picture, and then if they put it on the internet, some yo-yo is going to pick them apart. You didn't do the right thing. You should have done it like this. Actually, I ran into one of them a while back who criticized me for breathing, I believe. This is the Pleiades, M31. Rosette, M42. Flaming Horset. In this one, when I got it off the internet, I left his explanation on the top there. He's just using a 60 millimeter stellar view telescope, cheap telescope. They're great. I think they're about $300, something like that. I've got one, but I keep down in Florida. M64. That's reversed, but it's a North American nebula.
Yep.
You make these pictures, you can put them on the wall and let your neighbors and your family ooh and ah over them. They'll think you're an absolute genius, but we won't tell them that you don't have to be a genius to do these things. Now, what we've done is we've gone from this camera size, 1/3 to 1/2 to 2/3 to 4/3. That's this new camera that I just showed you. It's called a 294 from Sony. Panasonic has their own version. And that is what the state of the art is right now. Now, I thought I'd throw this in. This is my setup. It's on the back deck of my house. Visibility is not great. This is a Telrad finder. This is a stellar view finder that has my stellar view, or my Starlight Express with a camera in it. This is a 70 millimeter stellar view scope, and sitting down here is my 294 camera. And this is my pull master for getting a better polar alignment. Now, I've got to tell you what to me is a pain in the neck that I have to put up with. I use it primarily with a Macintosh telescope. I bought it originally for a PC, because originally the program was written for a PC. Well, my PC broke, and I went and bought a new PC, and it worked fine. Excuse me. Then Microsoft updated Windows 10. I haven't been able to get it to work since then. And this is a year and a half. So I'm forced to use it on the Mac. Another view of my setup. And this is just drawings of the Pullmaster. Now, M51. M101. M81 and M82. I can't remember which globular that is. These were done on my back deck last fall. It took me about half an hour to take all the pictures. And if I can do it, anyone can do it. They were taken with that Lodestar camera through my Stellar View guide scope. M81 and M82 again. Now, what does the future hold? Well, interestingly enough, there are enough entrepreneurs out there who realize when they can make a buck, they'll make a buck. This is called the Stellina. This is an all-in-one setup that'll do everything that I put together for probably a quarter of the price, or less. It's available in Europe now. It's going to be made soon. Made available in this country pretty soon. This is called the Unistellar EV Scope. So you can just go out and buy the whole thing ready to go. There's a little plug in there. You can plug it in. You can take it to your computer, or you can look through an eyepiece. It comes with an eyepiece that's actually a small video eyepiece. Another picture. Another one.
It does it all. Wow.
This is called the Zhiyun, obviously. I don't know who thought up that name, but if you want to learn more about video astronomy, this comes from Zhiyun ASI. Zhiyun is a supplier of astro equipment. They're very, very good. They send stuff out right away, but they have articles on their website about things that are pertinent to amateur astronomers. And I get a lot of my information from them and from Cloudy Nights. Now, this is the first page of Cloudy Nights on the internet, and there's actually a forum for video astronomers called EAA Observation and Equipment. There are others, a whole list of things. Astronomy equipment, cameras, how to do astrophotography. But video astronomy is getting popular enough that they actually have star parties for astrophotographers. Now, the nice thing about this is going to be done in October, by the way. This is this year. They don't bother you if you have your headlights on. They don't bother you if you walk around with a flashlight, because they're using video cameras. And you don't kill yourself by tripping over somebody's lines on the ground. Anybody here ever trip on the tripod? I have. Let me tell you, more than once. But it's a great way to do things. And here's a little more information about it. Anyways, that's how I got into video astronomy. Again, thank you, Bob. I appreciate it very much. The people who sold me the equipment appreciate it very much also. And that's it.
What's the adaptation to Macintosh? Can you do it with Macintosh? Macintosh computers. Can you go to Macintosh computers with much of these programs, or are they only geared to Microsoft stuff?
Most of the programs that I use are available both on the Mac and the PC.
Okay.
The only program that is not both is SharkCam. We keep hoping that they'll make it for the Mac. Every time you look around on a PC, you got, as I said before, you've got to load new drivers.
Right.
And there's something wrong with Microsoft for doing that. I've been out in the middle of nowhere, literally, but right next to Boomsville. And everybody starts cursing because they upgraded Windows 10 that day and nothing will work. And not just one person, but 3, 4, 5, 6 people. Believe it or not, I told that to the guy who used to run Microsoft, and he just got a smile on his face and walked away. I've met him several times. His cousin is a good friend of mine, so he comes to Detroit all the time. Quietly slips in, quietly slips out. But I got my revenge. He wrote an article on the Zoom, when Microsoft made the Zoom. He wrote an article that how good the Zoom was compared to the Apple product, and that even his uncle, Irv, wouldn't touch the Apple product. He would only touch the Zoom. Now, I have a picture, I sent him a picture of Uncle Irv with headphones on, holding my Apple in one hand and an iPhone in the other hand with a beatific smile on his face. He still has it on the wall of his office. And that's my revenge.
Great.
Yes?
What, maybe I missed it, what mount are you using now in the
I
telescope?
moved up. I started with that, the Orion mount, the Sirius. I moved to a GM8 mount from Losmandy. Then I decided I wanted a Losmandy G11, so I bought a G11. Luckily, my wife, you never tell her that you just bought a new mount. You always say, oh, I had this in the garage, or I had it in the office. So I bought the G11.
Welcome to marriage.
And at the time I bought the G11, there was a wait for an astrophysics mount of a year. So I ordered an astrophysics mount, which is a step above the Losmandy mount, thinking that I'd wait a year or two for the mount. 2 weeks later, I got a notice from astrophysics they had one available for me. Now, luckily, my wife didn't look at the checkbook. So I replaced the Losmandy mount with an astrophysics Mach 1, which is a superb mount, really good. Go-tos are extremely accurate. Actually, I'm going to talk about that in just a second. I'm going to add one more thing to what we were talking about. AP is a company just outside Chicago, western Chicago. And they've got some sort of a working arrangement with a company called Simulation Curriculum. Anybody familiar with them? They make a program called SkySafari. Now, SkySafari is a really great planetarium program for your iPhone, your iPad, or your Mac. They don't make it yet for the PC and probably won't. I've got it on my phone, I've got it on my iPad. But at this point, astrophysics will sell you their mount without a keypad. You can use your phone or you can use your iPad to control your astrophysics mount. Now, some of the other mounts are starting to do the same thing. And I would suspect within a couple of years, most mounts will come without a keypad and you'll be expected to go buy SkySafari or whatever its successor is going to be. And the go-tos are dead on. I can go from one side of the horizon, one horizon to the other, and what I'm looking at will be dead in the center, not even off a little bit. It's truly an unbelievable system. Losmandy makes a big fuss about having to build a program, a multi-site program on their mounts to show where everything is, so you'll have correct go-tos. They can go around it just by using SkySafari on their iPad or iPhone. I don't know why they don't do that. Maybe just stubbornness, or they think their system is better than anybody else's. Yes?
I was in Craig's basement in 1963, but I did not make a mirror there.
I did. And then I never mounted it. I made an 8-inch mirror. My father was an optician, and I actually started grinding lenses when I was about 11 or 12 years old in his office for him.
Lenses, really?
Lenses, yeah, eyeglass lenses.
Yeah.
And that's where I got my interest in optics. When I was in high school, my mother would drive us down to the Detroit Astronomical Society, and I can't remember the guy's name. He was an old man who had a house on 2nd Avenue.
Craig,
That was
Dr.
Craig.
Craig.
No, you're right. That's right. I
That's
forgot.
right.
And anyways, that's where I ground my mirror. My best friend Ernie ground a 6-inch mirror. I ground an 8-inch mirror. Ernie got a telescope when we were probably around 10 or 11 or 12, something like that. That was the first time I ever got a view through a telescope. We put in his window, and we'd look at the moon or the stars. We'd look for planets. We couldn't find them. I lost track of Ernie when he went to Cass Tech and I went to Central, Detroit Central. And strangely enough, I called Ernie last October. I haven't talked to him in probably 70 years, or close to 70 years. He's a marriage counselor in Berkeley, California. He trained as a physicist, got a master's in physics, and then couldn't get a job. So now he's a marriage counselor. But,
A little bit harder.
pardon me?
It's a little bit harder.
I don't know. I've only been married once. I couldn't tell you.
Well, your story is so very typical. You build the mirror, and you think, oh my God, I need a telescope to put this in. Then it gets tough.
Well, we used to make our tubes out of wood in those days. And I actually helped somebody build one. They were square tubes.
Yeah.
I don't know if any of you ever heard of these books. Ever hear of a man by the name of Albert Ingalls?
Yes.
Oh, yeah.
Communist Manifesto.
No. Albert Ingalls was a columnist for Scientific American. He wrote a book about making how to make a telescope.
With
I've got
Russell-
a second edition of it.
With Russell Porter.
Yes, that's right. Russell Porter wrote the foreword to it.
Well, Russell Porter made the illustrations for it.
Oh, really? Okay. I got it. Now, at the same time, there was another man by the name of Alan Thompson who wrote a book, Making Your Own Telescope. You had to make your own mounts in those days. We made them out of pipes.
Yes. Built to last 1,000 years.
Until you needed water pipes.
Yeah.
All the pipes in those days were made out of cast iron, or we didn't have steel, we had cast iron. There wasn't any plastic.
Of course not.
You know, I remember when the first ballpoint pen came out, 1945, right after World War II. They called it the Miracle Ballpoint Pen. They were lined up at Sears. I lived on Gratiot and Van Dyke in those days. They were lined up at Sears to buy a Miracle Ballpoint Pen.
You could write upside down with them.
That's right. You remember Silversteins?
No,
Yeah.
don't remember that.
I'll overlook it.
We moved there in 42, moved away from there in 46 because they were tearing our house down.
Good reason.
The house was built in the late 1800s. You had to walk outside to get to the basement. In those days, we looked at Gratiot and Van Dyke, as I said. In those days, I was out in the middle of nowhere. And then my father would take me all the way to the west side of town to fly model airplanes at James Cousins in Greenfield, which was a huge open field in those days. This was at the end of World War II, right after World War II. You can't believe how much I've seen change in the city.
I would like to point out that a good amount of the degradation of sky that you may have encountered in the bad old days was from coal-fired residential furnaces. I lived in a house circa 1950 that had a coal-fired furnace.
Sure.
And so in large cities like Detroit, even minus the industry, in wintertime, it must have been awful.
It was. My father had to bank the fire at night so it wouldn't go out.
Right.
Remember that? We were so happy when we moved to Broad Street between Boston and Kay. The house had oil an oil furnace. But most of the pollution we see now is really light pollution. There's some from particulates, some from water vapor. 9/11, when they grounded all the planes, the air got cleaner and you could see the sky a lot better. Yes, Dale.
My question is, what is magic about video astronomy that cuts out so much light pollution?
I think it's the frequency of the light that the cameras pick up. It just seems to cut through so much of the moisture and so much of the light pollution. Of course, you're using a long shade on the scope too, which helps.
It's the wavelengths.
Yeah,
That's why LEDs are so bad.
that's right. What's the city in Arizona?
Tucson.
No. There's a city now that's a dark sky site. Do you know about that?
Flagstaff.
That's right, Flagstaff.
Tucson is also, but it's not a.
No, it's not a.
That's Tucson is near Mount Lemmon.
No lights come.
For a while when I was in the Navy, I lived not that far from Mount Palomar. Palomar is about semi-useless at this point because of light pollution from San Diego.
Oh, that's not fair.
I agree.
That's, no, it's not, that assessment is not fair of the Hale telescope. With the newer technologies applied, they're doing spectroscopic work there.
Yeah, but they're not doing the photographs that they used to do.
No, of course not.
My son lives on Mount Palomar, not Mount Palomar, Soledad Mountain Road in San Diego. And you know, you can see the pollution, you can see the air pollution, the light pollution there. It's unbelievable. When I was in the Navy there, things were clean. I was in the Navy from 66 through 68, and I was already 30 years old when I went in. Anything else?
No, you were great.
Yes.
Have you gotten to try any of the all-in-one video? Have you gotten to try any of the all-in-one video astronomy telescopes?
They're not available in this country yet.
Okay.
They keep saying they're going to start bringing them over, but you know, don't hold your breath. I'm not
I'm just
going to.
curious how they, compare to an actual, full-scale amount and all that. I would expect it would be so much cheaper in construction than a full astrophysics mount.
Yeah, I expect it to be that way too. And they're not going to use the 294 chip from Sony or its successors. The 294 is one of the most sensitive and quiet camera chips ever made. I don't know if it's being used on any regular cameras at this point, but there is an extreme range of sensitivity in this thing. That's why I got those 4-second exposures at 5 a.m. That's why they came out so good. And it was very surprising to me that I get that kind of a picture with that little light. It was enough that there was just a little bit of a sky glow.
All right.
Thank you.